Spectrum Medical approaches cardiopulmonary support with the end goal of improving patient care. Every component plays an important role to achieve this goal, and we are going to provide an easy way to denitrogenate the blood to minimize and eliminate gaseous microemboli in the arterial line. Air is introduced into blood by suckers, vents, the open chambers of the heart, temperature changes, the air-blood interface in an open reservoir, and syringes and IV lines are obvious sources of air introduction. The inflammatory and coagulation systems are activated by gaseous microemboli, or GME. Endothelial and microcirculation dysfunctions are widely recognized to be associated with GME. Higher GME counts are associated with increased neurological dysfunction, delirium, AKI, and other morbidities that lead to increased length of stay and all have a significant financial impact. The ideal oxygenator transfers oxygen and carbon dioxide well, has low surface area, high air removal capability, minimizes inflammation and clotting, uses no plasticizing materials, has low shear stress, and offers optimal sampling port locations. Eliminate corners with a cylindrical design. Reduction in surface area. Reduction of the inflammatory response. Increased gas gradients across individual fibers per unit of exposed gas transfer surface area. And provide a specifically designed inflow vortex to vent gross air. Fibers are precisely positioned with spacers and maintained at the ideal distance from one another to achieve filtering while providing low shear stress values as well as high exposure of the red blood cells for optimal gas exchange per unit area of exposure. Cross-linked coating and avoidance of plasticizers minimizes foreign surface activation response. Careful positioning of sampling ports is considered for accurate blood sampling as well as being gentle to the blood. GME can create ischemia by physically impeding blood flow as well as stimulating the inflammatory characteristics that interfere with blood flow and metabolism. The sum of the pressure of each dissolved gas may equal up to 760 millimeters of mercury. Any higher and dissolved gas pressures will result in gas bubbles. Gas moves due to pressure gradients. Air bubbles contain about 78% nitrogen, exerting about 592 millimeters of mercury pressure. Responding to pressure gradients, gases move from an area of high concentration to an area of lower concentration. In a typical arterial blood gas, gas pressures are PaCO2 40 millimeters of mercury, PaO2 200 millimeters of mercury, and the remaining composition of gas is mostly nitrogen, exerting about 450 to 500 millimeters of mercury pressure. By decreasing the total pressure of the dissolved nitrogen, we make room to dissolve additional nitrogen into the blood. Removing nitrogen from the blood creates a large pressure gradient, so the nitrogen in a bubble dissolves into the blood. Spectrum Medical's ventilation technology and dual-chamber oxygenator are specifically designed to eliminate nitrogen in the sweep gas, while also limiting oxygen pressure in the blood. Creating a VQ mismatch by passing blood through the oxygenator while limiting the total surface area of ventilated fibers. The resultant PaO2 is much lower than if all the fibers were ventilated. The Spectrum Medical ventilator divides the hollow fibers into two unequal chambers, each with their own 100% oxygen gas supply. We first ventilate only the fibers in the smaller chamber, which somewhat limits the oxygen transfer due to available surface area. But the small chamber provides adequate surface area to control CO2. Blood flows through both chambers, creating a VQ mismatch. If additional O2 transfer is desired, we incrementally add oxygen to the previously unventilated larger chamber. We have normal CO2 control as well as PO2 control. By using 100% O2 while limiting PO2, the blood is denitrogenated, decreasing the sum of the partial pressures of dissolved gases. This provides the capacity to dissolve nitrogen bubbles. By eliminating nitrogen from the sweep gas, over time nitrogen moves out of the blood into the gas exhaust and nitrogen is not replaced, we have created the capacity to dissolve additional gas into the blood. This combination of limiting oxygen while at the same time denitrogenating the blood results in the sum of the partial pressures of all the remaining dissolved gases being lower than atmospheric pressure. Bubbles dissolve. EDAC studies demonstrate how GME are removed as they pass through a denitrogenated circuit. The choice? Do you want air or no air in your brain? This technique avoids complications associated with GME, better patient outcomes.